Number 1, dy by dx equal 1 minus cos x upon 1 plus cos x. Now we have to change it cos x into 1 minus 2 sin square x by 2 and cos x 2 cos square x by 2 minus 1. 1 will be cancelled from numerator and denominator, and here 2 also cancel and becomes tan square x by 2. Now dy equals sec square x by 2 minus 1 dx. On integrating, we get y equals integration sec square x by 2 dx minus integration dx plus a constant will appear. Take x by 2 equals t, so that half equals dt by dx and dx equals to 2 dt. Place here and you will get y equals 2 times integration sec square t dt minus x plus c, which becomes 2 tan t minus x plus c. So on putting the value of t here, you will get y equals to tan x by 2 minus x plus c, which will be the answer. Next question is dy by dx equals under root 4 minus y square. Now we can write dy upon under root 4 minus y square equals dx. On integrating, we get sin inverse y by 2 equal x plus c. So y by 2 equals 2 sin x plus c, and y equals 2 sin x plus c is the answer. Number 3, dy by dx plus y equals 1. So we can write here dy by dx equals 1 minus y, or dy upon minus dx equals y minus 1. When you multiply it by minus 1, then it will be. So dy upon y minus 1 equal minus dx. Now on integrating, we get log y minus 1 equal minus x plus c. Take the help of this argument. Now log y minus 1 equals minus x plus c. Apply this formula, you will get e to the power minus x plus c equal y minus 1. So 1 plus e to the power minus x into e to the power c equals y. Take e to the power c equals another constant capital A. As we see, e to the power c is a constant. So we suppose here e to the power c is a constant. Now we write y equals 1 plus a e to the power minus x. That will be the answer. And other question, question number 4, sec square x tan y dx plus sec square y tan x dy equals 0. We can write this question as follows, and on integrating we get log tan y equal minus log tan x plus log c, and we can have tan y equals c upon tan x, or tan x tan y equals c is the answer. Number 5, e to the power x plus e to the power minus x dy minus e to the power x minus e to the power minus x dx can be written as follows. And on integrating, integration dy equal integration e to the power minus e to the power minus x upon e to the power x plus e to the power minus x dx plus c. Take e to the power x plus e to the power minus x equals t. On differentiating with respect to x, you will have e to the power x minus e to the power minus x dx equals dt. So this will be the integration and answer. Question number 6, dy by dx equals 1 plus x square times 1 plus y square. Now we write integration dy upon 1 plus y square equals integration 1 plus x square dx. A constant will appear. This becomes tan inverse y equals x plus x cube upon 3 plus c is the answer. Question number 7, y log y dx minus x dy equals 0. So dx upon x dy upon y log y can be written as follows, and answer will be log y equals xc. So y equals e to the power xc is the answer. Number 8, x to the power 5 dy by dx equal minus y to the power 5. We can write this expression as follows, and on integrating y to the power minus 5 dy equal minus integration x to the power minus 5 dx. Apply the formula x to the power n, integration x to the power n dx equals x to the power n plus 1 upon n plus 1. Here, applying this type of formula we get, and a is a constant of integration. Now we can write this, and this becomes minus 4a. Take minus 4a as another constant c. You will have y to the power minus 4 equal minus x to the power minus 4 plus c. Take this term in other side, you will get the answer. Another question, dy by dx is equal to sine inverse x. So dy equals sine inverse x into 1 dx. We can suppose it 1 is present here. So on integrating, integration dy equals integration sine inverse x into 1. Apply the formula first function into integration of second minus integration d by dx of first into integration of second of whole integration. So y equals sine inverse x and into x minus 1 upon under root 1 minus x square into x. This can be written as, now we suppose here 1 minus x square equals t, and on differentiating it with respect to x, we have x dx equals minus half dt. So we write here y equals x sine inverse x plus half. Here is minus half now, so this sign will becomes positive half, and integration t to the power minus half dt plus c. So this equals y equals x sine inverse x plus half t to the power minus half plus 1 will be t to the power plus half. So under root 1 minus x square, and minus half plus 1 becomes plus half. So half cancel out. So remaining is y equals x sine inverse x plus under root 1 minus x square plus c is the answer. X tan y dx plus 1 minus e to the power x square y dy equals 0. We can write it e to the power x tan y dx minus 1 minus e to the power x square y dy. Now we change it as here, and let 1 minus e to the power x equals t and tan y equals u, and on differentiating with respect to x and with respect to y, we find these two, and on integrating du upon u minus here dt upon t plus log c, which becomes integration du upon u equals integration dt upon t plus log c, and now we write here log u equals log t plus log c. These two terms can be changed into multiplication form as log tc. On removal of the log from both sides, we get u equals tc. On placing the value of u, that is tan y, and the value of t, that is 1 minus e to the power x, this becomes tan y equals c times 1 minus e to the power x. Answer is here. Here is a question number 11 given as, and we write in this format. Here we see that this is a fraction. Now we change it in this way. This is called partial fraction. Here is a linear factor, therefore it becomes a upon x plus 1. And this factor is quadratic form. Therefore we write here bx plus d upon x square plus 1. Now this can be written as follows. Now we write in this format and comparing the coefficient of different powers of x, we have, see here, the coefficient of x square is a plus b, and here the coefficient of x square is 2, therefore a plus b equals 2. This becomes equation number 1. The coefficient of x is b plus d, here 1, therefore b plus d equals 1. This becomes equation number 2. And here a plus d is a constant term. This term is absent here, that is its value is 0. So a plus d equals 0. This becomes equation number 3. Now we find the value of a in terms of a, that is d equals minus a. Put this d equals minus a in equation number 2, that is b minus a equals 1. So b equals 1 plus a. Now this is substituted in equation number 1 and becomes a plus 1 equals 2. 1 goes in other side, and 2a equals 2 minus 1, a equals half. Putting it in 2, we get the value of b equals 3 by 2, and the value of d becomes minus 1 upon 2. On substituting in this, we have dy equals half dx upon x plus 1 plus half 3x minus 1 upon x square plus 1 dx, and as follows. And on integrating, we get this fraction. So y equals half log x plus 1 plus 3 by 2 into half log x square plus 1 minus 1 upon 2 tan inverse x plus c. Now in question given that when y is equal to 1, then x equals 0. So put y equals 1 and x equals 0. You will find that c equals 1. The value of c, when substituted in equation number 4, then we get the particular solution of the given equation as follows, which is a answer.